3-wire system and three-phase 4-wire system, where neutral is um, connected to the supply neutral. The load neutral is connected to supply neutral. That is what we have discussed so far. And also we have discussed about unbalanced 4-wire system, unbalanced 4-wire system, three-phase 3-wire system, and three-phase 4-wire system. So it is with Zn and without Zn. That is neutral impedance. Okay. So and also we have discussed about how the voltage, the neutral to ground voltage, that is V and O, gets varied due to the connection of neutral impedance. Here, yes. Now we shall solve one problem here, and then we shall take up the next type of connection, unbalanced delta connected load. Okay. Yes. One second. Okay. So take down the problem here. So a three-phase, 400 volts, 400 volts, 4-wire system has a star connected load, has a star connected load, three-phase 4-wire star connected load with impedances. ZA is equal to 10 ohms, ZB is equal to 50 plus J10 ohms, ZC is equal to 0 plus J5 ohms. So this is given. So you are supposed to find the line currents. The line currents are IAN, IBN, ICN. These things you have to find out. So N is 0 here, so it is nothing but what? IA, IB, and IC. Okay, and also you are supposed to find the neutral current IN. Okay, so this is what given. So you are supposed to find the line currents in the network, and also you are supposed to find the neutral current. So as we have discussed, the line current is equal to the phase current. In a star system, the line current is equal to what? Phase current. So for example, here, let this be A, B, and C, and here the currents are flowing, IA, IB, and IC. And this is what IAN, this is what IBN, this is what ICN. So here IA is equal to IAN, IB is equal to IBN, IC is equal to ICN. As we have discussed, so the line currents is same as phase currents in the star connection, whereas line voltages are same as phase voltages in delta connection. Okay, so that is nothing but voltage remains same across phase and line in a delta connected system, whereas in star connect system the line currents remain same as the phase currents. So now we are interested in finding out the phase currents. So that is to find the phase currents, you require the phase voltages. So this is what the phase voltage. Am I right here? So this is what the phase voltage. This is what the phase voltage. VAN. So if you know VAN, because you already know ZA, you can find IAN. Okay. Similarly, if you this is what the VBN. This is what VBN, and this is what the VCN. Okay, so this is VBN and this is VCN. So therefore, you can easily find out the currents when you know the voltage and impedance in the phase. Okay, so what should we do now? So let us write the formulas to calculate the currents in the phases. So let the current be IAN in A phase. For that, you require VAN divided by the impedance in that phase. Impedance in that phase is ZA. Am I right here? So VAN is the phase voltage in A phase. ZA is the impedance in phase A. Similarly, IBN is equal to VBN by ZB. Similarly, ICN is equal to VCN by ZC. So this is how you calculate the phase currents, which is equal to the line currents. This is what I see. So what is this VAN, VBN, VCN? So what is that VAN, VBN, VCN? So VAN is the phase voltage. How to find the phase voltage when you are given the line voltage? 400 volts is line voltage. So it's nothing but V line to line by root 3. Okay, so VAN is equal to V phase is equal to V line to line. So that is nothing but 400 divided by root 3. Similarly, VBN is equal to V phase, that is nothing but V line to line by root 3. It is 400 by root 3. Similarly, VCN is equal to V phase is equal to V line to line by root 3. That is nothing but 400 by root 3. So now you got to know the phase voltages from line voltages. From the phase voltages, you can find the phase currents using the impedances. Also, you can find IN. IN is equal to IA plus IB plus IC. That's all. You get the answers. Any doubts here? Now I want somebody to calculate the phase voltages first quickly. What is 400?
Sir, excuse me, sir.
Yeah.
Sir, there is audio lag, sir. Could you just please re-log in, sir?
What happened? Hello?
Sir, there's audio lag, sir. We couldn't hear what you told for past 2 minutes, sir.
Okay. Now is it audible?
Yes, sir.
Even now it's there, sir.
Yeah, wait.
So please, sir, re-log in, sir.
Now it's okay? Is it syncing?
Yes, sir. It's okay, sir.
Okay. So now we have to find here the line currents. To find the line currents or the phase currents, because in star connection the line currents is equal to phase currents. To find the phase currents, you require the phase voltages. To find the phase voltages, we are making use of the line voltages. In star connection, phase voltage is equal to line voltage by root 3. So obviously I can find VAN, VBN, VCN.
Using this phase voltage, I can find the line currents by making use of the impedance in the each phases. Okay? Yes. So solve for VAN, VBN, VCN quickly. So in that case, uh, you can take this as the reference, A phase as the reference. So the phase will be what? Angle 0. This is minus 120 and this is minus 240. Okay. Yes, I'm taking A phase as the reference phase. So obviously it is 400 by root 3 angle 0, 400 by root 3 minus 120, 400 by root 3 minus 240. Okay. Yes. I guess you can simplify it. Yes, we shall move on to the next problem.
So can we take plus 120, sir, instead of
Yeah,
minus 2?
yes, no problem, no problem. You can take it.
Okay, sir. Thank you, sir.
What is the total current you got, IN? Somebody solved?
Sir, 54.47 angle 18.64.
Correct, 54.47 angle 18.64 amperes. Yes. Next, so we shall take up one more problem. A three-phase four-wire system, 400 volts supply is connected to an unbalanced load, unbalanced star-connected load. So that is star-connected with ZR is equal to 10 angle 0, ZY is equal to 8 minus J6, ZB is equal to 5 angle 0, and neutral impedance is 0.4 plus J.1, sorry, J1. So find the phase voltages. Phase voltages means VRN, VYN, VBN. You are supposed to find these things and also the phase currents. So IRN, IYN, and IBN. Okay. Here there is a neutral impedance connected. So you need to use the different formula. Okay. Yes. What is that you have to first find out for? You have to uh, find out the neutral shift voltage VNO. The formula is ERN, that is VRN, or VRO, sorry, it is VRO into YR plus VYO into YY plus VBO into YB divided by YR plus YY plus YB plus YN. Okay. Using this, you can find VNO. So, how to find this VRO? That is the first thing we can find VRO. This VRO is equal to V line to line by root 3. It is nothing but 400 by root 3 angle 0. I'm taking R as a reference phase R. Next, VYO, again 400 by root 3 angle minus 120. VBO is 400 by root 3 minus 240. You got these values now. You know YR, YY, YB. What is that YR, YY, YB? It is nothing but YR is equal to what? 1 by ZR. YY is equal to nothing but ZY inverse. Both are same. And YB is nothing but ZB inverse or 1 by ZB. Both are same. So substitute in the formula. Substitute in the formula. VNO. If you substitute in the formula, you will get VNO as
over 15.9 angle 128.6 volts. Okay, so this is the neutral shift voltage. Okay, from this, you have to find out the phase voltage on the load side. So VRN, VYN, VBN. You have to find out these things. It is nothing but VRO minus VNO. Okay, it is nothing but uh, V by O minus VNO and VBO minus VNO. Okay, and after finding VRN, VYN, VBN, you can find the line phase currents easily, because you got the phase voltage, you can find the line phase current. Correct. It is IR is equal to what? VRN by ZR, or this is nothing but IRN. IYN is nothing but what? VYN divided by ZY. IBN is equal to what? It is nothing but VBN by ZB. This is as good as you can write in terms of line, IR, IY, and IB. That's all. Clear? Yes. So you can solve for the answers at your place. Next, we can move on to the next one. Last type of the load. Last type of load, you are very familiar with that. That is nothing but unbalanced delta connected load. Unbalanced delta connected load. That means until now we have seen a three-phase four-wire system and three-phase three-wire system. Here is a three-phase three-wire system. Okay, three-phase three-wire delta connected. Okay, so you will not get any neutral connection over here. Okay, so the phase voltages are same as the line voltages here. Okay, so in delta connection on the load, the phase voltage will remain same as the line voltages. Okay, yes. Now let us solve one problem quickly. A three-phase supply with line voltage V line to line as 250 volts has an unbalanced delta with impedances ZAB as 25J, ZBC as 20, sorry, ZAC as 20,
Hello.